In this tutorial, we're going to show you different ways we can import vector data into the software. We're also going to look at some of the common issues you may encounter whilst working with vectors created in a different design package, and we're going to show you how to solve those issues. Now, there are three ways to load vector data into the software. We can open an existing file with the imported vectors. We can actually create a new job and import vectors into the new job, or we can drag and drop those files into our workspace. So I'm just going to go ahead and demonstrate the first of those, which is going to be opening an existing file. So I'm just going to go ahead and firstly just close this, and I'm going to go to this option here to open an existing file. So just open that, and then navigate your way to the tutorials folder for working with imported vectors guide. Now you'll see two files in there, imported vectors demo and the imported vectors demo2.dxf. And down the bottom right hand side you'll see a drop down which contains all the different extensions for the different types of vectors that we can and files that we can import into the software. So if you just click on that drop down, you'll see that first of all we start with the vcarv file, so .crv. Now .crv is used for cut2d and vcarv, and if you have Aspire these will be CRV 3D files. Underneath that we'll have the DXF files and DWG files. Now these are common file types which are typically found with engineer drawing type packages. Underneath that we have the EPS and .ai files which are commonly created from artistic drawing packages. Underneath that we have the PDF and SVG. Now SVG is commonly used as a web graphic format as it uses the XML standard, and the PDF is a common document format. Now, if we import a PDF which has multiple pages, each page will be on a separate layer in the software. Now, .ai and .eps file formats do not contain layer information, whereas DWG, DXF and SVG files all will contain the layer information that was saved from the drawing package that you saved it from. So we're going to go ahead and open a DXF file. So if I wanted to, I can just select that from the drop down list there, and then I'm going to go ahead and select the imported vectors demo.dxf and click open. Now this will bring us into the job setup form, and you'll notice that it's already pre-filled some of the job size information for us, and it's done that by creating a bounding box that surrounds all of the vectors that we have imported into the software. But you'll notice our work area doesn't start at exactly x0, y0. So if I just scroll back on the mouse wheel a little bit, and x0, y0 at the moment is actually down here, and we do have an offset. Now the reason why we have an offset is unfortunately that these file formats do not include the original job size, hence we run into this problem sometimes. So what the software does, it automatically creates the job size for you by creating a bounding box around all the vectors, and then if the origin of that bounding box is away from x0, y0, it will actually just offset it using the xy datum position here, as you can see here. Now if we don't want this information, all we need to do is simply just uncheck that, and it will then put our work area into x0, y0 for us, like so. Now if we wanted to create some extra room or for the material around our vectors, all we could do is just simply change the height and width that we're working with. So I'm just going to press 10 inches in the width. Just going to tab down to move down to the height box and just type in 10 again there. And you'll notice it's added those extra inches away from, as we work in the bottom left hand corner as our XY datum position, it's added on that extra part of an inch to the right hand and upside of our job setup. So basically working away from our XY datum position. Now if we changed our XY datum position to be in the center like so, and then we change the height and width, we should notice that we'll get extra length around all sides of our job space. So if I just change the width to 12 inches and then tab down and change the height to 12 inches, you'll now notice that we've got extra material around all sides, equally distributed around our vectors. So that just shows you one of some common problems that we can have whilst importing vectors into our job setup. So I'm just going to change the XY datum position back to the lower left, and I'm going to press OK to accept all of these parameters, as we don't need to change the Z0 position and nor the thickness, as we're not going to be toolpathing in this tutorial. So I'm just going to go ahead and press OK there. So these are the vectors that we have imported into the software, and you can see that we've also imported the layer information. If we just go to the layers drop down box here, you see that we've imported 3 different layers. So layer 0, which actually doesn't contain any vector information, and we can tell that because we have a blank piece of paper icon next to the layer name. The layer default and red have been imported through that file, and you can see that they do have vectors on them because they have vector symbols on that blank piece of paper. So if we just turn off all of the layers and then just turn them back on, so you'll see that there's nothing appeared for layer 0. And if we turn on the default layer, you'll see that we have all of those vectors that were on the default layer, and if we turn on the red layer, you'll see that all the vectors that belonged to that default red layer. So that just shows you one way of importing vectors into the software. The other way that we can import vectors into the software is actually by importing them into an active job. So how we do that, I'm just going to go ahead and press File and then New. I'm not going to save any changes here. I'm just going to create a new job of 12 inches in width and a height of 12 inches. Now this might already be pre-filled in your job setup form for you. Going to be working with the XY data position in the lower left, and just simply press OK. Now the other way we can import vectors into a file, and there's a few ways which we can do that whilst we're in a job. We can either go to File and then Import Vectors. This will bring up the same dialog box. We can go to this option here underneath the file operations, so we can press that button and that'll bring up that exact same box, or we can press Control and I, and that'll also allow us to import vectors into the software. So what we're going to do, again, we're just going to go ahead and select those same vectors, and this time just press Open. Now you'll notice that these vectors have been imported exactly in the position, including the offset which they had originally when I demonstrated it previously with the creating the job from importing the vectors to begin with. And you'll also notice importing vectors in this method automatically selects all the vectors that we have actually imported into the software. Now this actually does come in handy, and you'll find out just why in just a moment. Now if we go to look at the layer information, so just go to the layer drop down, and you'll see we've got all the same layers that we imported previously, but we also have now a new layer called layer 1. Now the reason why we have this layer is because when we created a new job, we created an empty job, and when we create an empty job, the software automatically creates a new layer for you to create any vectors on. So now we have 2 layers that actually have no vector information on whatsoever. And in a large job where we've got quite a few layers with no information on them, we want to have an easy method to actually delete all those at once. Now an easy method to do this would be to actually just turn the visibility off of the layers that have vector information on them, just leaving the ones that don't visible, like so. Simply click on this icon here, select the merge visible, and that will then place all those vectors or all those layers into just one layer, and then all we need to do is right click and press delete, and it will automatically just delete those because it knows there's no vector information on that layer. And then we can just go ahead and turn back on the visibility of those layers. Now what I'm going to do next is show you more problems that we may run into whilst importing vectors into the software. So again, just click the icon here to import vectors, and we're going to select the import vectors demo number 2. Simply select that and then click open. Now you'll notice that we can't actually see any vectors that are different to the ones that we actually imported previously. Now there are 2 ways we can actually figure out if we have actually imported any vectors and where they actually are. Now the first option would be to actually zoom to fit. So this basically zooms to fit all the vectors inside our 2D view work area. Now we can find that icon underneath the view toolbar here, and this icon says zoom active view to the draw limits. Now simply click that, and you'll notice that our imported vector is actually in the top right, very far away from our XY 00 origin. And basically this has happened because the vectors here that we've imported have actually been saved that far away from the X0, Y0, and that's not in our 2D work area. So what we can do, as they are already selected, instead of actually zooming to the active drawing limits, what we could have done is actually just placed the vectors that are selected into the center of our work area. Now, an easy shortcut for that is simply to hit F9 on the keyboard, and you'll see that straight away that has now been placed into the center of our working area. Now, another way to actually zoom to fit is actually to press the letter F on the keyboard, and you'll notice that that now has zoomed 2D working area to fit all the vectors inside that 2D view. And once we've done that, we can simply just select it again just to put it into transform mode, and we can just maneuver this out of the way for the time being. Now, the next thing I'm going to show you is some different issues we can experience with imported vectors, and the easiest way to spot them with the software. Now, when we're working with imported vectors, the first thing that we should do really is to actually use the vector validator, and that will bring up any problems that we may have with these imported vectors. Now, we'll find the vector validator underneath the edit objects, and it's this option here that has the tick symbol, and you'll notice that it says the vector validator, check for potential issues with vectors. So if we click on this, this will open up the vector validator form, and at the top we will see instructions and how to use the tool itself, and then we'll have a list of each of the symbols which mean something different that is wrong or a possible complication with a vector. So at the top we have the 0 symbol next to a node, and this is a 0 length span. Now a span itself has a start point and an end point. Now a 0 length span is where the start and end point happen to be on top of each other, so there is 0 length in between each of the start and end points. Now the reason why this may be a problem is it can be an issue sometimes with creating toolpaths. The next option is overlaps. Now this would be denoted by an equal symbol, and this is basically where vectors are overlapping one another, so they're basically one on top of the other. The next is the intersections. Now this is where vectors are either intersecting, like a node on top of another node from different vectors, or it could be the fact that they're just intersecting. So like here, for instance, where we have vectors which are going across one another, that would be an intersection. So I'd expect that to be flagged up by a plus symbol. And all we need to do to actually find any of these issues is simply hit the search all button. So if I just press the search all, this should now indicate any issues that we have with our vectors. And as you can see, we've found one 0 length span. So somewhere in our vectors is a 0 length span. That's here, as you can see, in the snow white text. We also have 72 overlaps, and we have 165 intersections. Now if we just zoom into the top left here, as you can see, there's quite a lot of something being found here. So if I just zoom in, you'll see that there's a lot of overlaps and intersections. So that tells me that that is a duplicate vector. And if we just zoom out and then just scroll over to the bottom right hand side, we can see that there's quite a few symbols here. Now if you remember, so we have the long slim rectangles, 2 of them, and then we have a rectangle around the outside. Now you can see here that the 2 rectangles both have the equal symbol. That means there's overlap. So what that tells me is that them 2 here are both duplicate vectors. Now the rest of them are intersections, so you can tell that this vector is intersecting with that one. That's not a problem, but what gives a little something away is the fact that there's an intersection on the corners of this rectangle. Now if that is a fully closed object, there shouldn't be an intersection. So what that tells me is that the vector itself, the rectangle, is built up from 4 individual line spans, and it's not actually a closed vector. Now if I just exit out of the vector validator, I can try and verify this. So firstly, I'm just going to recenter my 2D view, so I'll just hit F on the keyboard, and then I'm just going to go ahead and select our rectangle. So I'm just going to go and click on one of the sides, and you can see that the vector validator was correct, that the actual rectangle isn't one closed object. It actually is built up of 4 different line vectors, as you can tell. Now if we were to box select this rectangle, if we wanted to select it for instance, and we just box selected around it from right to left, you can see that that actually selects as one whole rectangle. So if I select the actual rectangle to the left, you'll notice it is highlighted in a dashed pink line. Now that means if I just single click something and it has just a pink dashed line, that means it's a whole closed object. If I box select something, as I did all of these 4 open vectors, they actually do highlight all as if they are as one, because it selects everything within that box, whether it's closed or open. And that can be where we run into trouble sometimes when we box select things, because in doing that we can actually select duplicate vectors, and we can select all vectors which we believe to be closed and they're actually open vectors, like we've just demonstrated here. So if we go to the circles on the left and we just select those, so I'm just going to select the bottom left one, and then I'm going to shift and select the top left and then the top right circle, and you'll see another problem here. So you'll see that the bottom left and top right circles are both dashed pink lines, but the top left circle you'll see is dashed pink, but we do see the actual black solid vector underneath, and that is because that is a duplicate vector. There is a vector that is selected, but it's on top of the vector that isn't selected. But if we selected it in the box selection mode, you'll see that now highlights as if it's just one singular vector. So that is another issue that we need to be very aware of when we're importing vectors and we are selecting vectors, that we could by mistake actually select more vectors than we actually think we are selecting. Now this only would be an issue in toolpathing, because it would actually try and toolpath the same vector twice, or it would look as if it was, but it actually is doing 2 individual vectors. So let's say we were going to pocket that circle, it would do it twice because there is 2 vectors of circles in the same place. Now an easy way to actually select all duplicate vectors is actually to go to the edit options and selection, and we can select all duplicate vectors from the menu here. So if we just select all duplicate vectors, all we need to do then is right click and we can delete, and they will be deleted from our work area. Or, so we can see which duplicate vectors we had, we can actually just move them to a new layer. So if I just move them to a new layer, and I'm just going to call this duplicates, like so, keep the layer visible, and I'm just going to turn off the visibility of all the other layers, like so, and just deselect. And you'll see that these were actually duplicate vectors, like the vector validator actually pointed out to us. Now we can either keep these or we can actually delete them. So if we wanted to delete them, we can simply just delete the layer. So I'm just going to right click the layer, delete. It will ask us where we want to actually move the vector data to, so we can actually move those vectors to a different layer, but as I want to delete them, I'm going to set the delete option and then press OK, and you'll see that that has now removed the layer and also the vectors as well. I'm just going to turn back on the visibility of all the layers now. So now we don't have any duplicate vectors, but we still do have an open rectangle. So as you can see, if I just select the sides, so what I'm going to do is simply just box select all the vectors like so, then I'm going to join them together. And we can do this by using the Join Open Vectors tool. So click on the icon and that will bring you into the form, and straight away it will let us know how many of closed or open vectors that we have currently selected. So as you can see, we have 0 closed vectors and we have 4 open vectors. Now underneath that we get to specify a tolerance, and if it finds any open vectors within that tolerance that are around each other, it will actually try to join them as long as they are actually within that tolerance we've specified. If not, then it will still say at the bottom that we have 4 open vectors and 0 closed. Now as you can see at the moment, at 4 thousandths of an inch, we have actually achieved a closed vector. So we've got a nice and precise amount there. So what I'm going to do is I'm going to simply press join, close, and if I go to select that now, you'll see that that now selects all as one closed vector. So if we go back into the vector validator now, we should find that a lot of those problems have actually been rectified. So if I just press search all, you'll notice that we have 1 zero length span and 9 intersections. So you can see that we've actually removed all of the errors that we were getting here to indicate that we had a duplicate vector, and we no longer have the icons around the side to tell us basically that that was an open vector and not actually a closed rectangle as we first thought. So you can see that we've still got the intersections, and that's fine because that's where we've placed them. And the only other things that we have left to actually sort out is the intersection on the text here and the actual zero length span on the snow white text. Now this tool, the Vector Validator, will actually remove zero length span. So if I just press the button here to fix zero length span, you'll notice that that has now removed that and actually fixed that for us. Now if I just zoom in to the text, we can actually see what the problem is here. So if I just go here, and you can see that is the problem there. So you can see that it's intersecting because it's overlapping itself. So if I just close out of this and just press N on the keyboard to go into node editing mode, we should be able to easily see what actually is the issue here. So if I just select the vector now and I'll just drag this out, you'll see the problem that has occurred here. So you can see that it actually has intersected itself at the break point here. So an easy thing to actually do here would actually be just to remove that particular node. So if I just hover over that node and press the D key on the keyboard, that will then delete that node and actually sort that issue for us. So if I press escape, that will then get us out of the node editing mode and put us back into normal selection mode. If I hit F on the keyboard, that will zoom to fit. And if I go back into the Vector Validator now and press search all, we should only be left with the intersections which we already are aware of. So we have actually sorted out that problem really easily. So I'm just going to press close now, and the only other thing to actually show you is how to actually drag and drop vectors into the job. So all we need to do for this is I'm just going to zoom out a little bit, and I'm just going to go and bring up a folder containing the imported vectors that we've been working with, and all we do is simply select one and drag and drop them into the work area, and they will be positioned in such a way that the center of the vector will be the very tip of our mouse pointer. So if I just drag that into the work area, the actual center of that vector should be the very tip of that mouse pointer, like so, and you can see that there. And I'll do that again, just drag and drop, and the center should be exactly where the mouse pointer is, as you can see there. And that's all there is to it, and that gives us very precise placement of our vectors, and that doesn't take into account any positioning data that the actual imported vector has. So I'm just going to undo these, so I can either press the Control Z buttons on the keyboard, or I can use this icon up here. Now the banner that we've imported along with the Snow White text might not actually be as smooth as it first appears. If we go into node editing mode by pressing the letter N on the keyboard and then selecting the actual banner itself, you'll see it's made up of actually thousands of tiny line spans. So if we just zoom in and get a closer look at that, you'll see that each of these lines in between each of the node points is actually a straight line. Now if we wanted to actually edit the curvature of that banner, for instance, or we actually just wanted to make sure that we had a nice smooth curve for toolpathing reasons, we can actually change that vector into Bezier curves. So how we do that actually is we just make sure that we've got it selected. So first of all, I'm just going to press escape on the keyboard to exit out of node editing mode, and then I'm just going to select the actual vector itself. And then what we do is we go to the curve fit option, which fit curves to the selected vectors. So simply click on that icon, and you can see underneath the fitting type we have the Bezier curves. So simply just select that option there. Then we get to specify a tolerance. Now this tolerance is a very small amount that we can specify. We can obviously make it larger, but we want to keep it constrained to make it more precise to the original artwork itself. So I'm just going to specify a smaller tolerance actually to 0.04 for instance, and then I'm going to check to keep the sharp corners on, as I want to keep the straights as straight and the corner at where it meets the straight line as sharp as possible. And we get to specify the max angle there before it actually will turn into a curve, and then we get to choose whether we want to replace these selected vectors with Bezier curves, or it will just create another set of vectors. So I'm just going to go ahead and preview that, and you can see that's now simplified that vector for me. And once we've done that, if we want to accept those changes, all we have to do is simply press OK. And if we go back into node editing mode, you can see that we can edit the shape of this banner very easily now, as we only have a few control points and nodes to actually edit. So I'm just going to press escape just to exit the node editing mode and press F on the keyboard. And with that actually completes this tutorial. So thank you very much for watching.